Yeah, good evening, everyone. Switch on again. Let's start off. So the last thing we did was this problem. We are finding equilibrium problems. Okay. Next thing. So how do you find tension in a string? It's not that difficult. We have already done something like this, but there is some kind of a clarification. We need to be very clear about it because I did observe people do goof up. Uh, Let me show you what it means. Let's take two cases. Okay. Case one. Let's say we have a rope tied to a wall. Case two, let's say we have a rope pulled by two forces. Can you tell me what is the tension in both the ropes? Which rope will have more tension? Case one or case two? Case two, case one. And this is how, a company fooled its customers. You will see what is that. This is how you can increase sales. So when you know little science and if you're also a marketing manager, you can actually fool people. Let's see how that works. So first of all, if you want to find tension, others need to keep your cams on. Step one, this is what we do. So whenever someone asks you to find tension, and remember this, finding tension in a string is quite important. This thing will literally pop up in every chapter. Like, it comes in circular motion, it comes in elasticity, wave optic, waves on a string, sound waves, multiple places this thing will pop up. So this idea of finding tension, there are some chapters which totally depend on this one concept. So step one, and if you see, this is how I normally like to, I learned this way actually. This is how I prefer things. Keep it in steps. What I want you to remember is the process. I don't want you to mug up the problems. Most people have this issue, they try to remember problems. Isse kya hoga? If something changes in the problem, they don't know where to adjust. But when you remember the process, you know where to adjust. Just think of it like, you're cooking. If you go and ask your mom, aaj ka curry thoda tikka bana dena. Make it more spicy. Now your mom can't say, na, arre, but I didn't learn this thing. When I learned, it was only normal. She does know what to adjust, where to adjust. Instead of making for two people, you're making for four people, you know how to adjust. So the thing is, the adjustments are more important. So you should know the process so that you can adjust. So step one, assume the string is cut at the point. So wherever you want to find the tension, cut at the point where the tension has to be calculated. Be on time, everyone. Don't be late. Step two, now when you cut this thing, imaginarily you cut it, we get two parts. Choose any one. Draw FPD of any one. Step three, apply F is equal to MA. So let me show you how this works. I hope the steps are clear. So let's look at the case 1. Case 1, you have a wall. You're applying a force F. I want to find the tension somewhere in the middle. So I'll cut it here. So I'll get the right part, I'll get the left part. I'll choose anyone, I'll choose the right part. So this is force F, this is tension. Remember, strings always pull. Acceleration is 0. Therefore, I get F is equal to T. Straightforward, makes sense. Right? Now, previous page here. Clear? Now, I'll tell you one thing. Most people have this problem, they think case 1, case 2 are different. They're actually one and the same. Think about it. If I ask you to draw FBD of the full rope, how many forces are acting on the rope? Force F and the force due to the wall, isn't it? There are actually 2 forces acting on the rope. And since the acceleration is 0, F wall is equal to F. Isn't this the same thing as case 2? You're basically hiding that second force here by using a wall. When you saw the wall, you thought there is only one force, whereas in reality, on case 1 and case 2, both the cases you have same forces. So here also how to do? Cut it anywhere you want. If I take the left piece, you get the F tension. If you take the right piece, you get F tension. Acceleration is 0. Acceleration is 0. Now understand, this is the force due to the right part on the left part. This is force due to the left part on right part. Whenever you draw an FBD, you should draw the forces acting on the body. You should not draw the forces given by the body. This is force due to the left on right. I hope you're getting it. You can take any one FBD. And if you observe, you get F is equal to T. The tension is same in both the cases. What most people think is, sir, there is only one force acting. Sir, there are 2 forces acting. You're doing a mistake there. Even here, there are 2 forces acting. One force, external force, one wall ka force. Just because there is a wall, you thought there was no force and you thought there was a single force. So most people do this mistake, thinking since there are 2 forces, the tension should be more. Even worst part, people think like this. F and F will cancel, tension is 0. Do you know the meaning of that statement? FF cancel, tension 0. The meaning of that statement is, if I take you and if I tie you one side to an elephant and if I tie another side to an elephant, they're not elephants, but yeah, elephants, right? If I pull you with an equal force, you will feel comfortable. Isn't that the meaning of tension 0? I mean, you're still doubtful. You can ask 2 of your friends to catch both your hands and pull apart. As long as they pull with equal force, nothing should happen to you, isn't it? But that is not the case. If 2 elephants really pull you, you'll be torn apart into 2 pieces. Do you know that was actually a punishment? Not elephants, but they actually used to take a person, tie the hands and legs to 4 horses and pull them apart in 4 directions. That was actually a death sentence. That is how they used to kill people. Well, उस time Instagram, PUBG कुछ नहीं है ना, so people are bored. So you have to create invent different ways to have some entertainment. So executing people, that is one of the entertainment. So have a look at this. So remember this thing. In this case, both the cases tension is same. People think this will have more tension because there are 2 forces. What is happening is you are actually hiding the second force here with a wall. Both the diagrams are exactly same. Clear with this? Are in the page? Yeah. I hope everyone got this idea here. So remember, this tension is not 0. This tension is not 2F. The tension is F. Whenever you think it is 0, simply think of like that. If someone is pulling you both the sides with equal force, you won't feel comfortable. That uneasiness which you feel in your body is the tension. So using this logic, right? Ever heard about this thing, Levi-Strauss, the Levi's jeans, the denims basically. So denims, right, are actually during 1900s, it was one of the favorite what do you call dresses, for industrial workers. If you see these denims, right, are pretty rough and tough. You can use them without getting spoiled, or you can wear them. They're pretty strong. So all the industrial workers in US and everywhere, right, they used to use these denims a lot. So it was actually industrial workers' pants. Now we use it for fashion. People used to go it for work, for doing all jobs. So for them, the most important thing is not the blue color or not the holes, but the strength of the material. How strong is the material? So this company, what they did, they arranged during that time there were no TVs and everything. So they brought a denim, right, and something like this. They tied one side to the wall, and the other side they tied it to a horse. The horse was pulling with full strength, and nothing happened to the pant. And they said, "Look at our pant. Look at our quality. A horse is pulling, and nothing happened. That is the strength of our denims." And people were quite impressed. But a horse is pulling, and nothing happened. So sales went up. People were buying. Next year, the marketing guy, he said, they brought two horses that tied the same pant for two horses, and they pulled with equal forces. And now they said, look at this. This is even a better version 2.0. Two horses are pulling and nothing is happening to the pant. Are you getting the catch here? Now, what people see is one horse is pulling, so it is strong. Two horses are pulling, should be double strong, no? But the price of the pant is only 1.5 times. Isn't it a cheaper deal? So it is like one horse pant and double horse pant. ऐसा होता है कुछ grade. One horse pant is 100 rupees, double horse pant is 150 rupees. Automatically sales will go for this thing because two horses are pulling. Is that making sense? So if you know little physics, you'll understand that guy is bullshitting you. If you don't know physics, you'll count the number of horses and think, oh, this pant is double strong. That is what happens when you don't know a little physics. Where are you? Where is that? No, this is IIT monkeys. That is my hostel ka photo actually. That is how the monkeys used to roam in front of the room. This is damn thing. Kept it somewhere. It should be here. There. Pretty old ad. I think 1873. You're getting it? So that is the story of a single horse and a double horse ka genes. So be careful. Huh? The reason I'm showing the photograph now, remember this. Tension यहाँ पे F और यहाँ पे 2F नहीं है. Both will be F. Both are one and the same problem. You are just hiding one force with a wall. Is the concept clear?
Yes, sir.
Clear? Sure. Let's see a problem. So we have two walls here. We have a chain. Like this. Both are not at the same height. This angle is alpha. This angle is beta. This point is A, and this point is B, and this point in the center. Now I'm not drawing it properly, but it is kind of like this. Meaning this is the point where it becomes flat. This is points, the flat part. Mass of the chain is M. Ever seen garland in front of your house? When you actually put a garland on the front door, it hangs like this, but they're not at the same height. Mass of the chain is M. Think of like a garland hanging. So the question is, find the tension at ABC. A and B are the corners. C is the point where it is flat. C is the point where the chain is flat. Basically, the tangent makes a horizontal. Get this? If you put alpha is equal to beta, both the heights will be same. C is mg. Okay. I didn't expect that. You got an answer without alpha and beta. T sine alpha on A. What is T, Bhattacharyan? You're supposed to find T. Think, you got a minute. Draw the FBD of the chain, you will see. G by cos alpha plus cos beta. I think, Anusha, you're doing a mistake. You thought tension at A and B equal. Tension at A and B need not be equal. वो आपका क्लास का क्वेश्चन था. I know some of you are thinking that was this question when the string was symmetrical. उस केस में both the angles should be equal, ना? Then the tension should be equal. Tension at A and B is not equal. If someone has taken that, you have done a mistake. That's why I didn't keep them at the same height. TA is mg cos alpha, TB is mg cos beta. How are you guys getting that answer? Let me help you with this. See, I'll just draw this wire, okay, like this. So if you take this tension, TA, this tension, TB, this is alpha, so this is alpha, this is beta, so this is beta. Should I take it as T2 and T1? Chalega na, big deal. And look at the forces, the total weight will be mg. Now I don't know where will it act, but it will be mg. Components: TA cos alpha, TA sin beta, sin alpha, TB cos beta, TB sin alpha, sin beta. Forces in the vertical direction, the horizontal direction. In the vertical direction, TA cos alpha plus TB cos beta should be equal to mg. And horizontal direction, TB sin beta is equal to TA sin alpha. Get TB from here. TA sin alpha by sin beta. Take this guy and put it in this. You end up with TA cos alpha plus, that would be TA sin alpha cos beta by sin beta is equal to mg. If you take out TA common, you'll get sine beta cos alpha, sine alpha cos beta. That is nothing but sine alpha plus beta by sine beta. So from there you get TA is equal to mg sine beta by sine alpha plus beta. Sine A plus B formula everyone. तो एक बार TA आ गया तो TB भी आ जाएगा. I will leave that working to you. You can check it out. You can put this here and you'll get TB also. Check. I hope I understood how I got from here to sine alpha plus beta. I skipped a step there. I cross multiplied. It will be sine beta cos alpha, sine alpha cos beta, which is sine alpha plus beta. Normal force. Where is the normal force? You are not touching anything here. Strings will produce tension, right? That's not a block touching a surface, no? You can, if you want, you can call that normal force only as tension. Both are same. If a string is pulling the wall, you can call it tension, or you can call it normal reaction by the wall. You're talking about the same thing. We are just calling it a different name, isn't it? You won't have tension and normal reaction. दो force नहीं होगा. Everyone, please check this out. Now, can you find the tension at C? That is easy. Any doubts on this thing? Anyone not with any particular step, please ask me. Ritu, your cam is blank. Do something about it. Last class it was the same. I hope everyone has given the test. The paper will be, I'll be posting the results tonight. And I think there are 1 or 2 corrections you said, no? I'll get it done. That viscosity thing will get a bonus. I know most of you don't know what is viscosity thing. And the new paper will be released tonight. Do make sure to give this paper seriously. Tension at C, how do you do that now? Now see, again, what did I tell you? Wherever you want to find tension, cut it there. So this is point C, A and B. I'll cut it here. I can choose the left one or the right one. I will choose the left part. So at point A, the tension will be TA. This is alpha. At this point, the tension will be TC. This is actually easy. So this vertical component will be TA cos alpha. This will be TA sine alpha. I don't know the weight, but weight will be somewhere down. That much I'm sure. I don't know how much is that. And I would care also because horizontally the forces should be balanced. So TC should be equal to TA sine alpha. TA ka value, just dump it there, you'll get the answer. Easy. Now in this, there is one important thing if you observe. It doesn't matter. This is B, this is A. You choose any random point on the string, okay? Any random point on the string. And let's say this guy is making an angle theta, and this guy is making angle alpha. You'll observe, if you take this as tension T, this will be T sine theta. And the A ka component, if you see, this will be TA cos alpha, and this will be TA sine alpha. The horizontal component of tension of the string, right, is always constant. TA sine alpha is equal to tension into sine theta. Because the weight will never matter. Horizontal component of the string or horizontal component of tension on the string at any point is constant. This will be a theoretical statement question. it doesn't matter. You choose any point, the tension will be always constant here. So this will be also TB sine beta. Do check this out. That will be asked in a more than one choice as a statement question.
So can you move to the previous page for a minute? I want to check something. Yes, sir.
Yeah. Do check this out. Next thing. Any doubts on this? So remember that concept. So if you are hanging a rope, the horizontal component of tension will be same everywhere. T will change, theta will change, but T into sine theta will remain constant. Clear? All got this. Can I go ahead? Mehan, Neil, clear, na? Ali, got this? Swastika? Clear? Perfect. Next one. Let's get this one. Something similar. We have a mass chain of 10 kg hanging from two pulleys, 10 meters, blah, blah, blah. Find the tension at the midpoint A between the pulleys. Get this. 2 minutes. How do we do this? Everyone should give it a try. You got an answer, should definitely type in the chat box. And do make sure to give the test and everything. And some of you are still not sending reports. Some of you are sending. Most of you are actually ignoring not to send reports. What you're studying, how much you're studying every day. We'll be having a PTM next month mostly. So there I'm going to call out each one of your names if I don't have enough data. So yeah, and in no way I'm threatening you. I'm just telling you all that I can do is I'm just an innocent physics teacher. So I can just make the papers a little tough. So do take things seriously and start working. Like I said again, the most important thing right now is to develop good habits. Working consistently, working daily, even if it is little, even if you're putting every day 3.5 hours, but you have to do it daily. You're putting more, great, maintain that. And when I say studying, watching YouTube channels, reading textbooks, reading theory is not counted as studying. You have to solve questions. 25 questions per subject, at least 2 subjects per day. That should be your target. 50 questions per day, 25 questions for 2 subjects. If you're not doing that much, you're not studying. And let's be very clear, we are not here to do any research or PhD. Sir, should I read Rajni Holiday? Should I read that book? Should I read Feynman? Read Feynman. Like I said, you're not here to do PhD. Those are good books. You can do that once you go to IIT. Right now, let's crack the exam. How to do this? And most of you have the problem. My concept is bad. That's the questions nahi aa rahe. It is the other way around. Because you're not solving enough questions, your concepts are not getting cleared. Think about it. Till now in laws of motion, what the hell did I teach you? Tell me, you can count the number of concepts on fingers. First law, second law, third law, constraints, length of the string is constant. Ho gaya concepts. Bloody, we did 25 problems till now. Every problem is different. Let's get this. Any answers? You got a minute more.
Sir, when I cut the string from there on one side, if I want to calculate the tension after cutting, if you do it after cutting, they have to cancel the rest of the mass, or if you take the tension at the end before cutting.
If you're cutting here, ऐसा बोल रहे हो ना? If you cut it there, you got 2 parts, right? This part or this part. Which part you want to take?
Both are symmetrical, so it won't matter what which.
Matter. तो कोई एक part ले लेना ऐसा. बस हो गया ना? You have to draw FBD of this part only.
But that mass will be half or not?
Half, na? Then obviously, if you're taking half of the mass, so half the string, तो mass half ही होगा. Na? Vertical part has length. Arey, you guys are from English medium school only, na? I'm sure English medium में what is vertical? Now you tell me, is this vertical? This is vertical. और कुछ दिख रहा है क्या vertical यहाँ पे? हाँ, but in case you are from Marathi medium, I can totally understand. So I won't blame you guys. But I'm damn sure all of them pretty good English medium schools. Or you can tell me, sir, मेरे English में I got only 95%, so chalo fine, I accept. But you should know what is vertical, horizontal. Try. Or if you're from Don Bosco school, so then it's a different story though. The name is pretty interesting, Don Bosco. It looks like some Don ka school. But I'm not joking. There is a school like that, and there is also an engineering college in Chembur called Don Bosco Engineering College. So, any answers? Didn't get this thing. Let's see. A uniform chain of mass 10 kg, length 10 meter. So every 1 meter is 1 kg. Okay. The vertical part is 3 meters long. Find the tension at the midpoint of the string between the pulleys. Fair enough. So this part of the chain which is hanging, the vertical part, I'll just name them something. I'll just call this point A here. This is also A. It's the same point. Okay, we're already using A. So let's call this B here. So this is also B, and that is A. At this point, it is TB. This length is 3 meter. So 1 meter is 1 kg. So this weight will be 3 kg. So that is 30 newtons. TB is 30 newtons. So 10 meter is 10 kg. Therefore, it is 1 kg per meter. Now, this part which is hanging here, look at this thing. So this is 2 meter, okay? At this point, TB is acting like this. And this angle, I don't know. Let this angle be theta. And at this point, TA is this way. And this 2 meter ka weight will be 2 kg. Please check the FBDs. That will be 20 newtons. So from here, we get TB cos theta. So TB you can divide into components. TB cos theta, and this would be TB sin theta. So in the vertical direction, TB sin theta should be equal to 20. Horizontal direction, TB cos theta should be equal to TA. You're getting it? The mistake you guys are doing, I don't know this angle. It could be anything, isn't it? That is not vertical. It is making some angle, and I don't know what angle is that. Are you sure? Look at the diagram there. The center part is not making an angle there. It is not straight. Diagram aisa nahi tha. It is not like this. It is slack at the center. So it is making some angle, and I don't know that angle. So how to do from here? I don't want, I can even find theta if you want, but square them and add them. TB square sine square theta plus cos square theta will be 20 square plus TA square. And I know TB is 30, so that is 30 square minus 20 square is equal to TA square. That is 900 minus 400, 10 root 5 newtons. B option. I hope I did right. Yeah, if you want angle, you can divide them also. You'll get tan theta is equal to 20 by TA. They didn't ask you that, but multiple choice question I could have asked you. 2 by root 5. That is the angle made by the string in the with the horizontal. Please check. It's a good one. So you have to divide the whole thing into two parts. One 3 meter, one 2 meter. So this guy was 3 meter. This guy was 2 meter. This was 2 meter. This was 3 meter. So meaning this weight is 3 kg. This weight is 2 kg. And this tension is upward and this tension is at an angle. So this tension is at an angle here. Please check the FBD. All clear with this?
So,
Bino.
so we can do this either on the left side or the right side, right?
Same symmetry.
हाँ.
Anyone not clear with any particular step or not convinced, please ask. Anusha, clear with this? Adrit, Aditya, got this? Naulika, Yasha, clear na? Niranjan, Palaksh. Aryan, can I go ahead? Next one. Next one. So we have 3 identical spheres. Mass m, mass m, mass m. This distance is 3r between the walls. Three identical. We have drawn FPD for this, if you remember. 3 identical spheres of mass and radius r are placed between 2 walls as shown. Find all normal reactions. How many normal reactions are there? 6. 1, 2, 3, 4, 5, 6. Get all of them. Distance between the walls is 3r. Try. It's a good one. Just give it a try and get some water and come. Let's see. First of all, you need to get the angles. The normal reactions, right, will be acting towards the center. Na? They'll be like this. So, ye angle kya hoga? First, figure out the angles, geometry. Then the problem starts. Try. You got another 2-3 minutes. It's a good one. It's a little long, but it is a worthy one. Mg root 3 by 2. There are a lot of points, right? So I'll do one thing so that we all get the same symbols now. You can call this point 1, 2. So I'll use N1, N2, N3, N4, N5, and N6. So that you will understand what we're trying to find. So Adrit, when you said whatever answer you gave, which point is that you're talking about? There are 6 answers. For 2 and 4, both you got the same answer. No, that will be wrong. Chance ही नहीं है. Same तो नहीं आएगा. N1 might be right. देखना पड़ेगा. Now listen to one thing. In this all the 6 points, there is one point you can see and tell the answer. Which one is that? There is one point you can see and tell the answer.
6.
6th point. क्या the answer?
Be the weight equal to the weight of the ball. Yeah,
Which ball?
the bottom wala.
Nah, you're messing up. It is the weight of all the balls, isn't
All
it?
the 3 balls. All the 3 balls, sorry. Yeah.
Are you getting it?
Yeah.
Think about it. N1 is this way, N3 is this way, N5 is this way, 2 is internal, 4 is internal. The only guy who's balancing the entire weight is N6.
Yeah.
Is that making sense?
Yes.
The only guy who's balancing the weight, total 3 mg, is N6. There is no other one. So you can actually see and tell 6 ka answer. Remaining you have to solve. That will be useful to eliminate options. But anyways, we'll see. First thing, let's see whether we got the angles or not. So I will take this guy and this guy. So if we take from center to center, what is this distance? 2r. This was r. This is also r. Meaning this should be also r, no? Because total is 3r, isn't it? So if you look at this triangle here, this angle is theta. We get cos theta is equal to half. Theta is 60 degree. Is that making sense? It is given the horizontal distance is 3r. The distance between center to center is 2r. This distance is radius. This is also radius. So this should be also radius. Please check this out. The same way you can actually find for the upper one also. So this will be 2r and this will be r. So this angle, if you take it as theta, this is also theta. So basically theta is 60 for both of them. Check it out. Cos theta is half, cos theta is half. There we got the angles. Now let's draw the FBD. I'll draw for the upper ball. So this would be N1, your own weight mg. This is your N2, making an angle theta here, which is 60 degrees. So if you look at the components here, N2 sine 60 is balancing your weight mg. I'll be skipping the steps, so be careful here. This is N2 cos 60 and this is N2 sine 60. So from here I get N2 ka value directly, 2 mg by root 3. And I know N1 is equal to N2 cos 60. That would be mg by root 3. N1 aa gaya. Now if you take the middle ball, this is N2, this is N3. That is N4 and that is mg. that will look more complex actually. नीचे का ball नहीं था, that will be more better. I'll do one thing, I'll call the balls also with some names, A, B, C. So this is A ka diagram, this is C ka diagram. I'll tell you why I don't like that B ka ball. Unnecessarily you're getting three forces there. This thing would have been N4. This would be N5 and this would be N6. N6 ka value so we can already find. And you have your own weight mg. Should I have maybe N4 also? I don't know. No? I think I should take the middle ball. Yeah, I should take the middle ball option. Yeah. If you look at this angles, this was 60. This was 60. So components will be N2 cos 60. N2 sin 60. N4 cos 60. N4 sin 60. So in the horizontal direction, N2 cos 60 plus N4 cos 60 is equal to N3, and N4 sin 60 is mg plus N2 sin 60. There, from here I can find N4 and N3. Check. It's after this, it's just brute force. You literally have to draw the diagrams, divide the components horizontal, vertical, and solve. This kind of becomes like vector resolutions. Please check the diagram and the equations. Solving part I will leave it to you. You can handle that. Anyone didn't get the equations or the diagram or any force, please ask me. Once you've got this, your life actually becomes easy. Next part is more easy. I'll just show you that. I'll turn the page. Actually finding N1 and this thing will be easy. Reason, if you look at the forces here, this was N1, this was N3, and this was N5, and this was N6. You can clearly see N1 plus N5 is N3. Horizontal, meaning I'm taking the whole thing as a system. This is the FBD of all the three balls. And the weight will be mg, mg, and mg. And N6 will be 3 mg. There, you will get it directly, like, N5. From here, you can calculate N5. N3 minus N1. And N3 and N1 to calculated from the previous problem. Are you getting it? There's no need to draw the FBD of the third ball separately and do it. You could have just taken the whole three balls as one system and do it. Or you can take the third ball as a system and do it. You'll get the same answer. N4 is how much? 4 mg by root 3. Someone solved it. So mg by root 3, it seems. N3 is mg by root 3, it seems. So please do check. I'm not sure. But please look at the steps. You could have done the same thing with the ball C and get the FBD, you'll get the same answer. Now, this is a question where it is easy question, but lengthy one. That's what I'm saying. Don't get confused between a tough question and a lengthy question. A lengthy question just needs brute force. Just keep your mouth shut and keep solving. You'll get the answers. A tough question is something which you need to figure out what the hell is happening.
Sir, like this, N5 will be 0.
है, 0 क्यों आएगा?
mg by root 3, N1 plus M5 is M3. So both are same.
N1, N3 दोनों equal आ गया क्या? हाँ रे, 0 आ जाएगा. I don't think so. 0 आएगा. 0 नहीं आएगा. Something is wrong. Check your values ना Niranjan. So 0 नहीं आना चाहिए.
Sir, I didn't get
N5 कितना आ रहा है? N5 is N3 minus N1 ना?
Sir, N5 2 mg by root 3 आ रहा है.
But according to the one which you sent, N1, N3, देखो ना मुझे N1 mg by root 3 आया. You got N3 also mg by root 3. They're cancelling out ना?
No, sir, I forgot to put the slash there.
Oh, ठीक है. It is mg root 3 क्या? This is not mg by root 3. This is mg root 3. Okay. Solving part I will leave it to you. All got this thing? Any doubts on this? Please ask me. Here I took the FBD of all the 3 balls and I finished it off. Clear? Can I go ahead? Let's see one more like this, simpler one. Not like this, but a simpler version of it. So like this, we have strings attached to the different blocks. From a series of strings. So some of them are strings and rods, doesn't matter. This tension is T. Find T. The tension in the uppermost rope, I want to find that tension. And these angles are alpha, beta, gamma.
Sir, is
Find
it
the
in
tension.
equilibrium?
Yeah, equilibrium, obviously. We still didn't start making things move. After this, we'll make things move. Things will start crawling, flying, everything. Let's get this first. Step by step. When you learn, always go step by step. We don't jump directly to running part. First, we stand still, then we crawl, then we run. Then we bring air resistance, then we bring every damn nonsense. This, try, you got a minute. Anyone didn't get that diagram, please ask. So there are a series of strings and you attach 4 blocks, M1, M2, M3, M4, alpha, beta, gamma, theta. Now you need to understand from the hints, okay? I said 1 minute for the question. Meaning, that means I mean to say you can solve this question in less than a minute. Now you need to think, there are so many variables, so much is there, but I'm telling only 1 minute to solve. There is something you can figure out and do it in a much faster way. This is important. That is how you should think, huh? Because if this question comes in the mains exam, and if you actually try to write all the equations, you know, it won't take a minute. It will take at least 5-6 minutes. And mains, they'll never ask you a question which will take more than 2 minutes. Means there's some kind of trick, something you need to figure out. It is not about brute force solving. It is about thinking and figuring it out. Think you got a minute. See, these are the things will matter in the exam. It is not always about your subject. If it is about subject, right? When I was preparing, the people in my class, some of them have more subject than me, but no one scored better than me in physics. Yeah, it doesn't mean I'm very good. I used to mess up maths, so used to compensate. How do you do this thing? It's a single step answer, huh? Nah, Anika. You do come up with pretty interesting answers, but that's not the answer. It all depends on how you choose your system. You can take 1 block as a system, you can take 2 blocks as a system. You can take 3 blocks as a system. You can take 4 blocks as a system. Whenever you draw an FBD, there is no restriction whose FBD you're drawing. You can draw FBD of anything or any number of blocks. Aditya, aage answer. That's a big hint which I just said right now. Anyone else? If I can choose this entire thing as one system, right? If I just close this, I don't care what is inside, isn't it? All that I know is this total weight will be M1 plus M2 plus M3 plus M4 G. Make sense? And the only person who is balancing this is this tension theta, the vertical component. Because these forces will be horizontal, they will never balance the weight, isn't it? The only force which is balancing the whole weight is T sine theta. There, that's your answer. Think about it, because the other strings will not provide, the only person who can balance the weight is T sine theta. There is no other vertical force. So choose all the 4 blocks as one system. You can say draw FBD of all the 4 blocks. Because if you treat this entire green box as one system, all that I see is there are 1, 2, 3, 4 strings pulling horizontally, 1 vertical weight and 1 tension like this, isn't it? And the horizontal tensions will never help you to balance the weight. Ronak, you got it, but I think you messed up the M1, M2, M3 parts. You took all of them equal. Clear? Easy? So there, that is the idea. Suppose we want to find tension here, what will I do? Let's call this key dash. Yahan pe kya karna hai? Take these 3 as one system, na? You're getting it? Because this tension is balancing the weight of the 3 components. You want here tension, take these 2 as one system. So wherever you want tension, cut off there and take that the lower part as a system. Any doubts on this? All clear with this? Easy one. So there, that is about equilibrium. So when things are not moving, these are some of the varieties. Next thing. So what happens when things move? Can I turn the page? Anyone not convinced with this, please ask. Don't hesitate. If something you feel not clear or something, you can message me, you can ask me, you can unmute and ask, or you can always stay back after the class and ask, but ask, get it cleared. Don't hesitate to get your doubts cleared. This is not school. No one is going to shout on you. I'll be actually happy that if you get your doubts cleared, because if you get your doubts cleared, you'll improve. When you improve, you'll score. When you score, you are happy. I'm happy. It's a teamwork. That's what we're working for. And if you're asking some silly things and if you're goofing up, don't think like, what sir will think. Sir was more dumber than you. You're getting it? I added more hopeless things than you can imagine. So in that way, I will never try to judge you like, oh, you're asking such a silly doubt. I used to be such a dumb person. I used to think this and this are 2 different compounds. Why? Because H and C are reversed, so दोनों अलग compound होना चाहिए. Getting? You can't be more dumber than me. Getting? I had an equation 1 by 1.6. I didn't even realize I have to do fractions. I used to write the answer as 1.6 minus 1 and I used to look for the options. You are supposed to take a decimal out of this. So don't worry about that. Ask, get things cleared. Think about it. It was never my IQ that got me into IIT. Next thing. At one point, right, I started putting so much work, people started thinking I'm a genius. That is the sad part. All my hard work, right, they just throwed it into the dustbin by saying one word, genius. You know why people call you a genius? Ever thought about it? I'll tell you what I think about it, okay? This is what I think. Let's say your friend is working hard and he gets very good scores. You'll call him a genius. You know why? Because if you accept the fact that he's working hard and getting marks, means what are you telling? I'm not working hard, that's why I'm not getting marks. No? So instead of that, if you call your friend a genius, what will happen? Since my friend is a genius, he's scoring. I'm not a genius, so I'm not scoring. It is not my hard work that is a problem. I'm not a genius. Can you see what you're doing? You're creating a kind of, smoke screen for you. You're making yourself happy by saying like, वो genius इसलिए उसको आ रहा है. Hard work का कारण नहीं है. Because he's a genius, he's getting. Whereas on the other hand, I'm not a genius, that's why I'm not getting. That is a way, of keeping yourself happy by hiding the fact that you're not putting enough work. And this thing, I realized that I saw this in my 11th and 12th. I saw this in IIT also. I'll tell you one small story. Yeah? When I was in 5th semester, we had a computer coding class. It's a computer programming thing. I think it is MATLAB or something. So the teacher said very clearly on day one, right? She gave us a book ka name. He said, buy the book, read from that, learn the programming on your own. IIT mein aisa hota hai, some courses. Every week, I'll give you one assignment. 10 assignments, 10 marks. You can submit all the 10 assignments, you get 100 marks. Bas, itna hi course tha. You can come for doubts once in 2 weeks, ask doubts and leave. But most of the doubts you can find in YouTube, so you do the work. So teacher indirectly said, I'm not going to teach you any shit. You study on your own and come and give the submissions. And the teacher was really good. Huh? At least she told that. Our communication ka teacher was highlight. Out of 22 classes, he attended only 4 classes. Oh, to bunk master tha. Anyway, that's a different story though. So the first assignment came. I went through the thing and all. It was easy programming. Submit kar liya tha. I just spent like half an hour, 40 minutes. Second assignment came. It took me an hour or something. I submitted. Third was thoda tough tha. It took me 4-5 hours. Submitted. Fourth one was going over the head. I tried for around 3-4 hours and I gave up. Submit nahi kiya tha. I got a 0 in that assignment. And I said, yeah, hota hai kabhi kabhi, I will do something. But we are lazy people. Fifth assignment came and bloody, it was damn tough. Basically, it is leveling up. And I was struggling, literally struggling. I tried for 4-5 hours and kuch bhi nahi ho raha tha. Now I started telling a bullshit story to myself. I'm very bad at programming, isliye mera nahi aa raha. This is what happens when you don't get things right. You start making a story like, "Arey, programming बहुत tough hai." Getting it? I'm not, inclined towards programming. That is the reason I didn't take computer science. I electrical liya because I don't like programming. Maybe I'm not, I'm not the type of person who will understand programming and all. Some bullshit story. Fifth bhi submit nahi kiya tha. I got a call from the teacher. Arun, what is happening? Why didn't you submit the last 2 assignments? As usual, no, ma'am, I'm not well. There's, we keep giving some bloody excuses. She said, you have to submit the 5th one again. I'll give you an extension. Karke. She said, I'll give an extension for 2 days to submit. Kar. Whatever it is. I'll give you partial marks, whatever you have to submit it. I said, theek hai yaar. Then our class ka topper was there. Uska naam kya tha? Kishore, I guess. Kishore only. There were 2 people. I forgot the name. Theek hai, Kishore only, I guess. Kishore nahi yaar. Dusra guy tha. Chal, I forgot his name. But this guy, he was our class ka topper. Kishore was our actually class ka all India 22nd rank tha. This guy was all India 72 rank or something. But he this guy's a very polite guy, Bangalore guy, very cool guy. I went to him. He used to look a little weird. Einstein jaisa hota tha here. Getting it. So I went to him and I told him, "Yaar, bloody, I'm forgetting his name." I went to that guy and I asked him, "Arey yaar, how are you doing this? Give me some tips." You know what he said first thing? "Arun, how much time did you spend on program 5? I told him, "Yeah, maybe 4-5 hours." You know what he said? "Arun, I spent 32 hours on it." 32 hours on it. The only difference between you and me is, right, you didn't try enough. It is not about your IQ. You are as smart as me. There's no doubt about it. It is just that you didn't try enough. First, when I went through the program for first 7-8 hours, I didn't understand a shit. What the hell was happening? Then I started going back, started referring. I think around after 20 hours, I understood what is happening. I did some more study there and it just took me 2 hours to write the program, but 30 hours was a groundwork. So he said, put more time, you will get it. You don't need any tips. And he left. And I was sitting there and wondering, you know why? This guy, what the guy I talked about, in 25 years of IIT Madras ka history, He's the only guy who got selected into MIT, Master Institute of Technology, for electrical department for a PhD course. And this guy comes and tells me I took 32 hours to solve, and here I'm doing for 4 to 5 hours, and I'm calling myself, oh, programming is tough. I said, how dare am I? Matlab, what am I thinking? A guy like that took 32 hours to get in, to get the program, and bloody I did 5 hours, and I'm thinking like, oh, programming tough hai, mujhe nahi ho raha hai, and that and this. Whom am I bluffing here? It was a wake-up call. Said, yaar, I'm just not trying hard enough. 11th and 12th के बाद chill out कर लिया बहुत मैंने. I shut my mouth. I came back to the room. I started putting work. The teacher gave me 2 days ka deadline. I bunked all the classes. Literally, I was just sitting in the room. I spent around 25, 26 hours. I took little help from friends here and there. I completed the program and submitted it. But think about that. The guy who got All India rank 75, the guy in 25 years, the first guy to go to MIT, that guy took 32 hours to finish the program. And here I'm bullshitting myself saying programming is tough. I'm not designed for programming. And kitna time spent kiya maine? 4 hours, 5 hours. You're getting the point. It's not about your IQ. IQ, you'll always send someone much more than that. Remember this. That is the phase you're going through. When you're finding something tough, it is not that you're not designed for it. You're not putting enough time, maybe. Maybe you're not approaching the thing in a right way. Maybe you're thinking about it in the wrong perspective. But don't make bullshit stories about yourself like, oh, physics is tough, maths is tough, chemistry is bad, I'm not remembering, I'm not understanding. That's what we do. Instead of, having a clear perspective that I'm not doing something enough, we start blaming the things, saying like, this is happening because of that. Do remember this story. It helped me a lot. I think that was a kind of, wake up call for me. Like, I remembered that is how I used to be. I used to put a fight where I never used to get. But after going to IIT, thoda zyada chill out kar liya. Got busy into having too much fun and all. I forgot that I used to be a fighter. I started becoming a person who complains a lot. I changed. You can choose. You always have 2 choices. You can complain or you can fight. We have enough people who are complaining anyways. So next thing. So how do you solve problems when things start moving? Step 1, choose your system, draw your FBD. Now, but when that guy said 32 hours, my mouth was open and I was thinking, what? How the hell someone can spend 32 hours on bloody one programming in a week? Yeah, he got a week's time. I got my answer in 2 days. I spent 26 hours in 2 days. I understood how we did it. Draw FBD with appropriate symbols. Second one. So this is the first thing, I taught you already how to draw an FBD. So we know that. Second step, assign accelerations. So if there are 5 bodies, assign I1, A2, A3, A4, A5. And find relation between them using constant motion. This also we learned how to do. This was the second part. So till now, what I taught you was all basics. So now your basics are ready. You know how to draw FBDs, you know how to find constraints. Find relation between them using constraints. Third, choose your coordinate system. Choose your X and Y axis. And resolve the forces and accelerations along them. This is vectors. Did you observe? You know everything. We just have to combine now everything. That's how you learn. Stick to the basics. Accelerations along them. Step 4. Apply F is equal to ma. Along the axis and solve. Check it out. So this is the framework that we'll follow for every problem. Mehan Venkatesh comes on. Any doubts on this page, please ask me. Clear? Let's see some problems. Let's start with an easy one. 27. So we have a block. We have a block.
So can you go back to the menu?
Hmm.
Yes, so thank you.
You are applying a force F. You are applying a force F. Smooth ground. Find the acceleration and the normal reaction between them. And normal reaction between the blocks. Let's get this. Right, Ali. F by M. Hey, Ronak. Are you typing it wrong here? By 3M, Mehan, what did you type that? F by 3M is fine. What is 3M again? See, first one. Step 1, choose your system, draw the FBD. So 2M, M. Forces, F, normal reaction, normal reaction. Step 2, define accelerations, A and A. Find the relation between them. They'll be equal. Why? They're touching each other. Rigid body constraint. Step 3, write the force equations. F minus N is equal to mass into acceleration. N is equal to mass into acceleration. This is step 4. Solve. Put N is equal to MA here. You end up with F minus MA is 2MA. A is equal to F by 3M. Substitute back there. N is equal to F by 3. Easy. Or you could have done like this. Step 1, choose your system and draw the FBD. I will take the whole system as a system. Acceleration is A. You get directly F is equal to 3MA. Get the acceleration in one step. Now you want to find normal reaction. If you want to find normal reaction, you don't have an option but to cut it here. Cut karna hi padega, because if you take the whole thing as system, N always becomes internal force. Choose any one block. I will choose the 2M block. You can choose the M also. So this is the normal reaction and this is the acceleration. So N is equal to 2MA. A is F by 3M, 2F by 3. So you can choose M and 2M separately, or you can choose both as one system to get acceleration. But if you want to find normal reaction, blocks ko separate karna hi padega. So here, this is the statement here. So if two blocks or two systems have same acceleration, we can treat them as one block. In this case, M and 2M both have same acceleration. So you can treat them as one single block and solve. If two systems have same acceleration, we can treat them as one block. Please check how I did this. I just followed the process. Choose your system, draw the FBD. You can choose your system as M, 2M or M plus 2M. Second, draw the accelerations A1, A2, both will be equal because rigid body constraint, both are pushing each other. Step 3, resolve your X and Y axis. So this is X, this is Y. Fourth step, write the forces in the X axis. Y to nahi chahiye. Fifth, solve the equations. Check it out. It's a straightforward one. Simpler version. I'm just trying to show you how to use that steps. Let's do a better one. Please ask me anyone confused with this. And if you observe, both the normal reactions are not same, F by 3 and 2F by 3. Be careful with that. Even though everything looks identical, it depends on from which side you're pushing. So pushing a 2M block and small m will actually give you low normal reaction. The reverse will give you more normal reaction. Any doubts on this? Anyone didn't get this, please ask. This would be a CET level question. Even if it's a mains question, they'll ask you to find the ratio of normal reaction in case A and case B. That would be better. All got this? Can I go ahead? Clear, na? Ritu, Anika, Palaksh, Abhinav, got this? Aryan, Ronak, clear, na? Got your mistake? I think maybe you didn't type properly, I guess. Next one. Next one is a better one. So we have a block like this. 2M. Block M. This is theta, meaning both can slide over each other. This is force F and this is force 2F. Okay. So the first question, find the normal reaction between them. All surfaces are smooth. The second one, find the maximum value, max F, so that the blocks do not slide over each other. And if you push them really hard, you can create a situation like this. Like this, no? You're getting it? There is a possibility this M will start climbing this 2M. I don't want this to happen. So what is the maximum force you can apply? If you apply too much, they will just move across, you know, that they'll slide over that incline. Get this thing. This is a better version, better than the previous one. First thing, find the normal reaction, assuming they're not sliding. Second case, if they're going to slide, find F ka value, maximum. Try, got 3 minutes. Again, remember the process is still the same. Draw the FBD, accelerations, force equation, solve. The process which we write is valid for everything. What is A, Niranjan? A is not given. You have to give me the answers in the terms of variables that I gave you. I gave you F and M and theta here. So your answer can't be with something else. Be careful with that. 4f by 3 sine theta. Might be right. I don't know the answer. Let me check. Anyone else got that? We have one answer so far. Is it acceleration? Shape part. Okay, where is mass there? Dimensions are wrong. There's no mass term only. And theta nahi aayega acceleration mein. Acceleration was easy. No, wait, sorry. You're finding normal reaction, right? I'm sorry. Might be right. I'm not sure. I thought it's acceleration. What is the first part? I will take the whole thing as one system. Acceleration be a. So I get 2f minus f is equal to 3ma. So acceleration is equal to f by 3m. Choose any one block. I will choose the 2m guy. Draw the FBD. 2f. This is the normal reaction. I'll do one thing. I'll take the m guy because I need to find that also. No? This is n. This is f. You could have taken 2m also, but this is the acceleration a. What other forces are there? mg. A normal reaction on the ground. So we are talking about this n. So this is 90. So this was 90 minus theta. So this angle was 90 minus theta. So this components will be n cos 90 minus theta, that is n sin theta, and this guy would be n cos theta, and this was n. Check your FBD. Horizontal forces. N sin theta minus f is equal to mass into acceleration. And n sin theta is equal to f plus ma, and ma is f plus 3, so 4f by 3. I think you are right. Right, Anika, you got that right. So normal reaction will be 4f by 3 sin theta. This is the first part answer. What about the second part? Find the value of f so that the blocks don't slide over each other. How do you do that? Think, I'll give you a minute more. I hope you are getting what I'm doing here. FBD, equation solving, keep it very systematic. The more systematic you have and tough problem comes, you'll know what to do. But if you do it in a weird way without drawing FBD, without drawing diagrams and equations, that is a problem. The difference between, a wild person, right, who's pretty strong, or a proper fighter, both of them are deadly. But a fighter is more deadly because he can use the same amount of energy to hit the more critical spots. He's more systematic in destroying the enemy. And that's why you learn martial arts. It is always about that. The whole point is that it is to maximize efficiency because you're more systematic. If you see these boxers now, before every match, they actually train with their coach. You know what the coach does? Let's say if you are going to fight with a boxer who is like 6 feet tall, and let's say you're only 5.5 feet. So when you're punching this guy, your hand will go to a certain spot. So as a coach, your job is to make sure, that gloves will be there, right? I have to make sure whenever you're hitting, you're always hitting at the critical spots. So you're not randomly putting the gloves anywhere you want and that guy is hitting. The coach always puts the gloves in such a position that is a critical spot of the boxer you're going to fight in the next match. And they do this for thousands of times before the actual match. Thousands of times. You know why? During the middle of the boxing, they're getting hit so badly, they lose consciousness. Some of the boxers by third round or fourth round, right? They don't even know where they are, what they're doing. But every punch they beat, right? They are actually fighting with instinct. Every punch they throw is going to the critical spot. Even though this guy doesn't know where is that spot, he can't even see half of it properly. Systematic practice makes you strong. So when you're solving, it is okay. I'm telling you, instead of solving 300 questions, you solve 100, 120 questions. But understand and solve. Why am I solving this? What am I doing in this? What kind of mistakes I can do? Is there any other way to do this? Can I make this question more tougher? I think you should spend more time like that analyzing a question rather than doing a lot of questions. At least for physics, that's how it works. Why do you take the normal at an angle? Why not parallel to? Array, normal reaction is always along the common normal, right? Isn't that the statement, Aryan? The normal reaction, normal. What word is dekho? Normal means what? Perpendicular to the surface, isn't it? Here. Normal. Sure. Force can't be parallel. That should be friction. Anyways, next part, what is this? So tell me one thing. If they're going to lift off, like this, what will happen? Means it will lose contact with the ground, na? If it lifts off, this implies Ng has become 0, isn't it? If this is going to go off, matlab Ng 0 ho jayega, na? You will lose contact with the ground. That is the reason when you lift off, actually. Maybe I draw this thing wrong. It would actually kind of look like this. Isn't it? This is how it looks actually. Means the end ground becomes 0 if you lift off. So from here, try to find n ground. So n ground plus n cos theta should be equal to mg. So we get n ground is equal to mg minus n cos theta, that is 4f by 3 cot theta. And this should be greater than equal to 0 because you don't want to lift off. So from here we get f should be less than or equal to 3 mg by 4 tan theta cot theta. That's your answer. As long as the force is less than this value, you won't lift off. So since you don't want it to lift off, Ng should be greater than 0. Ng should be greater than equal to 0 for not lifting off. Please say. Aryan, I hope you got the answer for your question, right? Yeah. Do check it out. Basically, I draw the diagram previously wrong. It should have been like this. If you're lifting off, it goes off like this. You lose contact with the ground. So Ng becomes 0. So as long as you're touching the ground, Ng is greater than equal to 0. So that is the answer. So maximum force is 3 mg by 4 cot theta. I can write that as tan theta also. 3 mg tan theta by 4. If you exceed this force, they will lose. They will start sliding. Clear? Easy? Good one. You just need to put your steps properly and solve. Any doubts on this? Next one. Turn the page. Neil, clear, na? Arjun, Udayan, clear? Rehan. Next one. We got a table here. This is mass M. This is a pulley here, and this is another block M. This is angle theta. Both are same mass. The ground is smooth. And from here to here, this length is h. Case 1, initially blocks are at rest. Case 2, I'll call this, I'll just make this 2m, okay? Initially, m is going down with speed u. Find the acceleration of the blocks at this instant. Right now we build case 1. Case 2 is homework. Case 2 is pretty good. That will be proper advanced question. Case 1 is also good. If the system is starting from rest, find the acceleration. If the system already has initial speed, you find the acceleration. The second question becomes pretty deadly. So do make sure to try that at home. That will take time. Let's do case 1 right now. Anyone not clear with the question, please ask.
Sir, what is h for the height?
H is H only, it is given. You will need it for the second question. Try to get the case 1. Case 2 will be homework. Make sure to try that. Just give it a try. Any answers? The steps are still valid. Draw your FPD, find the acceleration relation between accelerations, force equations, and solve. G cos theta by 2 plus cos theta. This is the acceleration of which one, Anika? There are 2 blocks, M or 2M. I'll tell you what most people do, okay? See, this is what people do. Tension, mg, tension. So this component is T cos theta. T cos theta is equal to 2m into acceleration, and T is equal to mg. Mg cos theta is equal to 2m. Mm cancels, A is equal to G cos theta by 2. This is a blunder. Why? People do this. And worst thing, ये option में होगा exam में. ये होगा option. This is a blunder if you have done this. Can someone tell me what is the mistake here? Do you understand what I did? Can you tell me what is the mistake? This is wrong. Pakka wrong. Acceleration is the same. That is right, but what is the mistake here? Anyone? Anyone? Ali, Anusha, what do you think? What is the mistake here? Vartika, mistake. What is the mistake that I did? Yasha, इसमें क्या mistake था? What I showed you right now. नहीं, इस side ही होना चाहिए ना. Horizontally it will go. Because you know this mg block will never lift the block up. 2m can't fly. Niranjan?
Sir, T is not equal to mg.
Yes,
T is
sir.
not equal to mg.
MG.
आपने assume कर लिया यहाँ पे this block is at rest. You're getting the mistake. T is not equal to mg. If you're saying the 2m block is moving, meaning capital M is also moving, na? That was a mistake. So see, this is how the FBD looks. This is tension. This is theta. Let this be A1. This is 2m. This is M. This is tension. This is mg. And this is, let it be acceleration. Let's call this guy A1 and let's call this guy A2. Step 1, choose your system, draw the FBDs. Step 2, define your accelerations and find the relation between them. So relation between them will be t into minus a1 plus t cos theta into a2 is equal to 0. a1 is equal to a2 cos theta. This is a blunder. Can someone tell me why? And luckily you'll get the answer. If you have done this, luckily you'll get the answer of case 1. Case 2 will trap you. This is a blunder. Can someone tell me why?
So theta is changing.
Theta is changing. If theta is changing, you can't use relation for accelerations. Are you getting it? You can't use this. We can't use this when theta is changing. We can't use that power method for accelerations when theta is changing. Luckily, it works here. The problem looks very innocent. So you're actually supposed to use it for t into velocities. Minus v1 plus t cos theta into v2 is equal to 0. We get v1 is equal to v2 cos theta. Differentiate with time. This will become a1. This will become cos theta dv2 by dt plus v2 minus sin theta d theta by dt. Luckily, since v2 is 0, the second term becomes 0. You get a1 is equal to a2 cos theta plus 0. Are you getting this? Because the initial velocity is 0, it didn't create a problem for you. The answer comes same, but you should know why you did this thing. Now are you understanding why second part ka initial velocity u is given? That is what will change the whole problem. Now the second term won't be 0 for case 2. So people who have done this without thinking, right? You got the answer, but you got it in a wrong way. So be careful. a1 is equal to a2 cos theta. Please check this out. And then you're done. So force equations, t cos theta is equal to 2m a2. This guy will be t minus mg, up positive, down negative, m into minus a1. I'll stick to the convention which we learned in kinematics. And then what do you want to find? a1, a2, no? Now take this t guy and dump it there. 2m by cos theta, and a2 will be a1 to cos square theta. Take this and put it here. We end up with a1 2m. I'm skipping steps. Plus 1 plus m is equal to mg. Mm cancels off. We get a1 is equal to g cos square theta by 2 plus cos square theta. That's your a1, everyone. And you'll get a2 also from there. Please look at the steps. If that body had been moving, it would be a big mess. That second term won't be 0. You need to find d theta by dt. इसके लिए h चाहिए. The question becomes quite a good one. Please have a look at this. So there are multiple things where you can do mistake. This was a mistake which luckily, right, you will still survive. Anyone not clear with this, please ask. Be careful here. T is not equal to mg. That is another common mistake. You will take t is equal to mg and they solve the problem. And worst thing that option will be there. Once you see the answer, you won't even think twice. You'll mark it and come. Problem वही है. You will realize it's a mistake after the exam gets over. Clear with this? Any doubts on this? Can I go ahead? Next one. Let's see how many of you remember this. Helix. 3.5 turns ka helix. Height is h. This is the second time you're encountering this. Radius is r. Smooth helix. So on this helix, someone kept a massless bead, bead of mass m. So this bead is going to slide. So the bead starting from rest slides on the helix. Find the time taken to reach the ground. Let's get this. In case someone forgot what's a helix, in kinematics, I guess. There, it is the same thing, 3.5 times helix. I hope you remember this property of a helix. When you open this, the diagonal of a rectangle becomes a helix. This was the question for 3.5 times helix. When you open this, it actually becomes a diagonal of a rectangle. Try, you got 2 minutes. Anyone not clear with the question, please ask. Remember this. This again we'll do in circular motion. We have a helix with friction and the bead is sliding with constant velocity. So kinematics, NLM, circular motion, magnetism, you'll encounter helix 4-5 times. Think. How do you know this? If I open this, this height will be h. And remember, 1 turn is 2 pi r. So 3.5 turns will be 3.5 into 2 pi r. Hope you remember that. Every time you open the helix, for each turn, the horizontal distance will be 2 pi r. So this you can refer to kinematics page 15. There we did a little more on this in more detail. You can check that out. And this guy is angle theta. So the whole question has become as if you have a block of mass m here sliding on an incline, na? Isn't it? When you open this entire helix, it becomes as good as an incline with height h and the base is 7 pi r. So we get tan theta is equal to h by 7 pi r. So if you write the forces on this body here, you have mg sine theta, mg cos theta, normal reaction. And always remember, forces will be on the body, accelerations will be outside the body. Don't, forces should be drawn on the body. Accelerations always keep it outside. So I'm choosing this as my x-axis and that is my y-axis. So we get here mg sine theta is equal to mass into acceleration. There's only one force. So acceleration is equal to g sine theta. And this total length will be root over h square plus 49 pi square r square. I'll call this s. Using the equation s is equal to ut plus half at square kinematics. Acceleration is constant. S will be root over h square plus 49 pi square r square is equal to half into acceleration is g sine theta into t square. Shift everything, that's it, you'll get the time. you have converted the helix into a incline. So a block is sliding on an incline whose angle is theta and the length of the incline is s. And acceleration is g sine theta. So s is ut plus half its square, you get it from there. Clear with this? So the main headache in the problem is converting the helix into an incline. Once you got the incline, I'm sure it is easy. Do check this out. Ask me if you're confused.
Then we can do this question using work power energy.
Time कैसा आएगा मेहन?
No, V के बाद kinematics लगा के.
I'll tell you one thing. You will never get time using work power energy. Never.
उसके
हाँ,
बाद
मेरा
kinematics लगा के.
क्या करोगे kinematics लगा के? You'll get velocity and then think now. What will you do? You tell me what will you do. You have an idea, good. Now proceed
we'll
with the
get-
idea and try to figure it out. Then what will you get?
We'll get the velocity, हाँ, but then acceleration.
Acceleration तो यही निकालना पड़ेगा end of the day. I know you're trying to use v is equal to u plus at. तो ये तो निकालना है ना. Means you have to do this. All clear with this? Any doubts on this? Ali, clear na? Ritu, all clear so far? Udayan, Niranjan, clear?
Yes,
Abhinav?
sir.
Clear? Perfect. Last one for the day. We have a rod here, mass m, length L, x is equal to 0, x is equal to L. Someone is applying a force F. To F, mass m, length L, x is equal to 0, x is equal to L. F, someone is also pushing with F. Mass m, length L, x is equal to 0, x is equal to L. Find the tension in the rod at a distance x from the right side. 3 cases. Find tension in the rod at a distance x from the right end. I can say find the tension as function of x coordinate. 3 different questions. Same rod, mass m, length L. First case, you're applying a single force. Second case, you're applying 2 forces opposite, 2F and F. Third case, you're applying F and F. Both are pushing in the same direction. Find the tension in the rod as a function of x coordinate. The right side is x is 0, left side is x is equal to L. Nah, Adrit. That is wrong. Think about it. If someone is pulling you and pushing you from the back, your hand will be stretched, but your backside is getting compressed. You will be in a pretty awkward position. Finish up. Last one for the day. And this question you will encounter again in elasticity chapter. There I'll ask you find the elongation in the rod. Like I said, finding tension in a rod or something, strings, right, is itself is a main concept in some chapters. If you know how to find tension, some chapters get over. Try. 3 minutes. Again, the steps are same. Choose a system, draw the FBD, find the acceleration. Wherever you want to find tension, cut it there. So just to give you a little help, I'm asking you tension somewhere here. So I want you to cut it here and find the tension there. That's what I'm asking. So after cutting, then draw the FBD of that part and finish it off. I think I'll give you a minute for the first one, then I'll show you. Right, Yasha, that is right. Keep going. We have one answer so far. Others answers? Adrit, Aditya, Answers, Ronak, Udayan, Anusha, answers. Yeah, that is right. First one. Maulika, Rehan, answers. Venkatesh, no answers today. Make sure to do all these ones we did in the class again, after going home. Questions are, some of them are tough, some are easy. Trust me, you didn't do any work. I showed everything, you just listened to it. So don't be under the delusion that, oh, you understood how to do the problem. Take a rough paper tomorrow. See each question, try to do them on your own again. Trust me, you will learn a lot more. Don't open the notes after 1 week. You won't remember anything. You have to do this within 24 hours. It'll take 20-25 minutes, right? But if you wait for a week and then open the notes, it'll take 2 hours to understand what the hell you wrote. Consistency, daily work. That's what will make you strong. Don't behave like it is school, studying 1 day before the exam. How to do this thing? First one, see. F, acceleration, A, F is equal to ma. You want to find tension here, cut it here, x. You can choose the right part or the left part. I will choose the right part. This is F, this will be tension, and this mass will be small m. Mass will not be capital M. What is the mass? For length L, mass is m. For length x, the mass is small m, unitary method. M is equal to mx by L. So mass of this piece is mx by L, and this is the acceleration will be same. So F minus tension is equal to mass into acceleration. So F minus tension is equal to mx by L into F by m. Mm cancels, we get tension is F into 1 minus x by L. Please check. And I didn't ask you this, but if you try to plot the graph, tension versus x coordinate, we have a graph something like this. The tension starts here at F and becomes 0 here at x is equal to L. That is a graph, T versus x graph. Second part, 2F and F. Try, you got a minute now. I think now you understood what to do. 2F and F, second part. Get this. Find the tension as function of x. Idea is simple. Find the acceleration. Wherever you want to find tension, cut it there. When you cut it, you get 2 parts. You can say, sir, can you show with the second part? I can do that. If I take this part, this length will be L minus x. So there's only one force tension. So this mass will be m by L into L minus x. So we get T is equal to m dash into A, which is m by L into L minus x into F by m, which is F into 1 minus x by L. Same answer. Doesn't matter which part you take. The left or the right will give the same answer. So the main thing is that when you're cutting, mass won't be same. It will be mx by L. Second part ka answer F2 L minus x. Yeah, that looks right, Aditya. Try everyone. Any doubts on the first part? Look at the second part. 2F, F. Acceleration. Acceleration is F by m. You want tension here? Cut it here. You can take left part or the right part. I'll take the right part. 2F, tension, acceleration. This mass will be mx by L. Story is the same. 2F minus T is equal to m into acceleration. So 2F minus T is equal to mx by L into F by m. So tension will be F into 2 minus x by L. If you try to plot this graph, tension versus x, when x is 0, tension is 2F. When x is L, the tension is F. You don't touch 0. The graph goes from 2F to F. C part, you're pulling and pushing it there. Try, you got a minute for the C part. Idea is the same. If you see nothing is changing, you only the acceleration, the terms and all, the process is the same. The process is the same. Get the C party, got a minute. Finish it off. Last one for the day. And make sure to definitely try all these problems before the next class. Ideally speaking, if you can do tomorrow, it will be great. The more you wait, the more it will decay. You won't remember anything after 2 days. And if you can do it today night or tomorrow, it will be great. You just need to spend half an hour. Trust me, it will help you a lot in the long run. Most people wait for a week and they open the notes and they'll find half of the thing looking new. So you actually spend more time wasting. But by tomorrow, you will still remember most of it. And that's the reason I send you the recording after every class. Even by chance you're struggling, you didn't get confused, you can always refer to it immediately. But do it in a day, maximum 1 or 2, not more. Answers for the third one. Third is interesting, actually. Acceleration is 2f by m. Cut it here. X. F. Tension. Acceleration. And this will be mx by L. F minus t is equal to mx by L to f by m. We get tension will be f into 2x by L minus 1. So this is actually, when if you take x is equal to L, you get positive. X is equal to L, you get negative there. What is happening here? Tension versus x. It is going into negative part. So tension is F here. This is L by 2. This is minus F here. The meaning of this is this rod now, the front part of the rod is elongated. So tension is actually pulling. The back part of the rod is compressed. That is the meaning of negative tension. The front part of the rod is elongated, the back part of the rod is compressed. That's why the tension is becoming negative. So negative tension indicates it is getting compressed. Remember, rods can pull and push. Positive tension indicates it got elongated. It's pulling you. Clear for this? So tension is decreasing and becomes negative. Means again it will increase in the negative direction. Means it is pushing there. So the graph would be interesting if they ask you for graphs. Do check this out. So make sure to try this thing again. Want it to be 1 minus 2x by L? Yeah, it will be 1 minus 2x by L. Yeah. Clear? There. So we did almost, I think, 32 problems so far. Today only we did around how many? Yeah, this was the thing. 24, say. 8 problems we did. That's it. Normally every class we do something like that, only 6 to 8 problems. So it don't take much of our time. So do make sure to try them all again. So next class when we meet, we will do more things. Now we will see pulleys moving, blocks moving, all that stuff. So next class will be even more better problems and more higher ones. So make sure to revise till here and come. Right. So any doubts, anything, please stay back or else you're free to leave. I'll see you guys next week. The test will be online today night or tomorrow morning maximum. And I will post the results with the corrections for the